Hi, so let's now talk about events. What are they and their pros and cons? First, I'm just going to create an actor. Let's name it example. In here, if you go to an event graph, you're going to be presented with three different types of events. So basically what events do is trigger something, some logic, and there is different types of events and how they can be triggered. So you have some default events like a begin play, which basically trigger when the game starts. And event tick, which basically triggers on every tick. Those two are generally some of the most used and known ones. You also have stuff like end play, and there is some damage systems because Unreal already have some incorporation of damage, and some other stuff that you probably won't use much. Maybe actor begin overlap and stuff like that, but in general, most of them you won't even use. So except these events, other events that you can have are input events. This basically means that when the player clicks a button or does something on the keyboard or moves a mouse, you can basically record that and trigger events when something like that happens. Third type of events that you can have are custom events. These events basically mean that they can be triggered whenever you want, so you have more control of it. To create a custom event, what you would do, click right click and type custom, and then you have add custom event. And in here you can set the name of it, add parameters, and basically then you're gonna have to decide when to call this custom event. So if I want to call it on begin play, I would type custom event, and since we haven't named it anything else, it's gonna be called custom event. And then you can call and trigger it. A lot of things in blueprints are driven by events. You're gonna be using them a lot, so you kind of need to get used to them. So these were a few examples. Now let's go through pros and cons of events. So first pro of events is that you get bunch of lifecycle events. So for every actor, pawn, character, game mode, stuff like that, you're gonna get bunch of events by default, so you don't have to kind of manage from scratch every time you create a new blueprint. So you have these things by default that you can use or not use, so I can at any point just delete them. And if I ever want to use them again, I can go in here and find them, or I can also click right click and type, let's say, end play, and find that event. So that's the first con. The next one is something we already talked about. So custom events, you can create as many custom events as you want. You can name them stuff. Test event. You can add as many parameters as you want. So you can kind of customize it. One thing about events is that they don't have outputs. Unlike functions, you can't have any outputs, so they only have inputs. So if I called this test event, I can customize these parameters, but I don't have any outputs, so I'm going to have to manage that in some other way. The third pro is you have event overrides, similar to how you have function overrides, where if you have a parent blueprint, you can override the child, or sorry, if you have child blueprint, you can override the parent functions, the same way you can do with events. So if I click add call to parent function, I can override, or I can actually call the parent function, but if I don't call this event, I can just override it and ignore whatever parent was doing with this function. The fourth thing is event graph has inherent support for delays and timers. So this is something that you won't see in functions. Function needs to be executed immediately, while events can have stuff like delay. So if you type delay, you can just basically wait a second if you want something to happen and then trigger it after. You also have timers. So if I type set timer by event, this basically means that I'm going to trigger this event. So if I create a custom event, let's call it delayed event, I can basically trigger it after some time. So I can set it after, let's say, 1 second. I can trigger it once, or I can set it to loop, which basically means it's going to trigger every second indefinitely or until I manage it in some way. So we're going to go over timers in some other time, but just get you a bit more familiar with them. You have this timer handle structure, which basically means that you can kind of manage this timer. So let's say you put this timer to run indefinitely, but maybe you have some condition where you want to stop this timer. Basically, you can then call this handle and say clear and invalidate. So you can basically call this somewhere else and basically you can stop this timer from working. So really good stuff. So you have delays. If at any point you need something to be happening over time, you're usually going to be using events for that, not functions. You also have timelines for delayed actions. So this basically means I can create a curve in here. So length is, let's say, 5 seconds. So over 5 seconds, I can create some type of curve with the output. And that output can be a float, a vector, or whatever I want. and then I can update it on every tick, and it can be, let's say, over 5 seconds. And also we have when stuff finishes. So really cool stuff. And this is, by the way, all kind of inherent or kind of set up by default, so you just have to kind of call it. You don't have to do any setup of your own for delayed functions. Next thing is you can pass parameters. So we kind of briefly went over this, but if you create a custom event, this of course does not apply for pre-made events or events that you already get, but for a custom events you can just create parameter, set whatever you want it to be. So integer, you can do arrays, sets, maps, set it however you want. And then when this, you can also pass it by reference if you ever want to do that. So if you want to kind of change some variables from some other place, inside this event you can pass it by reference. And now if I call test function, I can change this. I can, let's say, make a map, modify it, customize it, so you can basically use parameters here. Next pro is event dispatchers. So for that I kind of have a little visualization to kind of explain, because it can get a little bit confusing if you're dealing with them for the first time. So basically in blueprints what you can do is kind of attach an event to another event, and then say when the event 1 is triggered, it calls and triggers event 2. So basically kind of like subscriber listener pattern, where you have an event that has a list of other events that it calls when that event is called. So let's say you have an event 1 on some blueprint, and then you have another event on a second blueprint. And let's say you want this event 2 to trigger when this event 1 triggers. What we can do is, you don't have to do it on begin play, but that is one example, is on our blueprint that has event 2, you have to, in some way, to let the event 1 know which other events you want to call when this one is called. So that is what this binds to node does. It tells event 1, hey, I want you to call event 2 when you are called. And then when you call that, so that is kind of one functionality that you're going to have to set up. And then you have your second event, and then whatever this event triggers you can have. Now this event dispatch system can work on multiple events. So if you have, let's say you have this event 1 calling event 2, you can also have calling it event 3, event 4, event 5. So it can have as many objects connected to it as you want. One thing to keep in mind is that the more events that this event 1 calls, the more expensive it's going to be. So it has kind of a linearly scaling performance overhead. So if you have one call in this event 1, and if you have 10 calls, these 10 calls is just going to be 10 times more expensive, because it has to do 10 separate calls for 10 separate events. So that's just one thing to keep in mind, where event dispatching is nice, where you can have multiple subscribers to one event, but it also has a cost, so you never want to have too much. You never want to rely on a bunch of these calls. So now let's see how that works practically. Let me delete this example. So we have this test actor and event dispatch. So event dispatch basically has our event that we want to call and attach other events to. And then this test actor has the bind to that I was talking about, and then we call some event. So let's go first through the event dispatch. So what's happening here is that I can create as many event dispatchers as I want. So I can do another thing here. It can also have input parameters if I want. So basically a typical event. The only thing is that this event is special, where it can have subscribers and then call them. So what I'm doing here is on event tick, this actor that has event dispatch is just going to call this event every tick. And that basically means whoever subscribes to this event is going to call it on every tick. Then we have this test actor. One also little drawback of the event dispatch system is that you have to have direct reference to it. So I had to get the reference somehow. So I used get actor of class. Of course, you can use it in many different ways. You can have a stored variable. You can get a reference to this object maybe from another object that has the reference to it, stuff like that. So there is kind of different ways to get the direct reference, but the easiest way is this, so I just use it for this example. So we have to create first the bind to. So basically what this means is we want to connect event 2 to event 1, and this is where we get the reference to event 2. And when they are connected, when the event 1 triggers, we're going to trigger event 2, which basically prints hello. And then you also have a different thing, which is unbind. So if you want, at any point you can unbind this connection, basically saying, okay, I don't want to have this connection anymore. And just for an example, I said that when this event 2 triggers once, we just want to unbind. But you can of course unbind this at any other point if you want to create more complicated event dispatch systems, or you have some condition where maybe this event 2 needs to trigger 10 times and then stop triggering. how you can unbind it. So yeah, just for an example, to kind of show both bind and unbind, I connected it like this. Now let's click play and see what happens. So I also, yeah, by the way, added these two, so test actor and event dispatcher, I just added them to the level, so I have them right away so they can call each other. So if I click play, we can see I get this hello message, and that's basically because it went into this print string and then unbind it, so it only happened once because we disconnected it. But if I disconnect this, we can see this hello is going to happen as much times as the event one is called, which is every tick, which is probably 60, 80, 100 times a second, depends on your frame rate. So yeah, that's kind of generally how the system works. So to bind this, you have few options. I can do bind event one, or I can also do assign, which is usually what I do if I have a new event that I just want to create at the same time. So this kind of does it for you. It creates the event that is binded and then also creates the bind. So it's kind of just a little quicker than just bind and then you have to create your own event. And also this can get like a bit of spaghetti code. So what you can do is type create event. And what this node does is basically has this little node that connects to another event, but you don't have to have this connection. So if I connect it here, I can select to which function I want to connect it to, and then I can select event 2, and now I don't have to have that line connected. You can imagine if you have 5, 10 connections, just having these branches going everywhere, it just creates a mess right away. Now we also have this other connection, which we can kind of mitigate by maybe storing this variable. So we can call it something like that. We can also connect it like this. Oh yeah, we need to disconnect it from here. And then we can get the reference from here. And now we can see how it's a bit more clean. We'll have those connections and things are a bit nicer. And if you click play, it works the same way. So you didn't change any functionality, just made some cleanup here. Okay, so that was 6th Pro for events. Now the 7th Pro is interface events. So when you are using interfaces, which we're going to cover in the future. So let's call it new interface. If I create and name it test function, interfaces can basically be attached to actors and then basically trigger functionality without other actors knowing specifically which actors they're triggering it to. So it's kind of ambiguous in that way, but we're going to cover that in the future. Just to kind of give a general idea of this pro is that you have this interface that you can basically attach to, let's say, our actor. So I can go here and type new interface. And when I attach it to this actor, we're going to have this test function that we created. And this test function can be represented as a event. So that's kind of one thing where you can have also delayed functionality. So this interface doesn't only create functions, it can create events. And while we are here, what we can also do is convert events to functions. So if at any point you want to have a function instead of an event, you can convert it and then this event too becomes a function. Of course, if you have had any delayed functionality and now this event, it gets complicated because now this event doesn't work. But if you have few things like this or delays, converting it to a function is going to give you errors. So you have to be careful with that. But this is kind of another functionality that you can do with events. And the last pro for events is that there is some replications options for them, which is really cool that Unreal gives you. So if I create a custom event, what I can have is this replication. So how this custom event replicates, it can be multicast, basically meaning it replicates on all of the clients in the server. So if you have your game and you have a server and then you have clients, let's say 3 clients, what can happen is if this event is, let's say, triggered by the server, it can basically trigger separately on every client. Or if it's on the client, you can trigger on every other device basically. Then you have run on server, so this is going to run on server only, and you can run on owning clients. So again, if you have like a server and few clients, if this client calls the event, not the server or the other client will know about it. And if you call this event on the server, even client won't trigger it, so it's only going to be triggered on the server. So that's kind of how you manage replication for multiplayer games using events. And you can also do not replicated, of course, which just basically means it's going to be, if it's a multiplayer, it's going to work basically the same way as run on only client. But if it's a single player game, then you don't really care about replication there. Now let's go through cons. So I don't think there is many cons for events. They're generally good. Of course, you have some performance considerations because there is a little bit of cost calling events, as anything when you call it, but you have to kind of just generally manage your events. You don't want to have like thousands of event calls a second or not second, a frame or something. So first con is delays can get harder to debug. So when you have stuff happening over time, that's just gonna add another complexity where you can have, let's say, 0.5 second delay and it triggers some event, and you might think this error is triggered somewhere else because the event was triggering later, but it can be some event from the past just having a delay and triggering it. That's one con. Then we have the second one, which is just generally debugging is limited. So we have this print string that I already showed you, where we can kind of get some printing on the screen. So if you just type print, you can get print. You also have a log, so if you want to do stuff in the output log, you can show only here instead of on the screen. Next thing that you have is breakpoints, which basically means that when game starts evaluating this node, it's gonna freeze, so you can kind of stop at any point. So if I have this and click play, you can see my game stopped and it's saying, okay, we are at this point right now, you wanted me to stop. What now? Basically I can then go to the next, or yeah, go farther away, which we don't have anything. But yeah, you have breakpoints, you have prints, and then you have some different debug stuff that are kind of newer and that can help, but for some things it cannot compare to C++. Of course, blueprints have other stuff that can kind of help with debug, which is this reference view, so you can see all the dependencies for this blueprint, or like this size map, so you can kind of see how much memory and what is called or what is loaded into memory when this blueprint is loaded, stuff like that. So there is some stuff like that that is actually maybe better than what C++ can offer, but for a lot of stuff you only have basically prints, breakpoints, and then if you want to get fancy, you have some options with debugging. And the third thing is that when you're calling events to other, unless you're of course using interfaces, if you're calling events to other blueprints, you are using direct referencing, so that means that things get highly coupled, especially with event dispatchers. So if you're using event dispatchers, you're going to have direct references. That basically means that now that I have this get actor of class in my test actor, that means that every time I load my test actor, I'm going to load into memory event dispatch, even if maybe this event dispatch shouldn't be used in a game, it will still be loaded into memory. So that can be a disadvantage if you are not paying attention to it. So if I click right click here, size map, we should see our event dispatch here. So we can see that we are basically loading this event dispatch, even though we might not want to, because yeah, we're gonna have to have that direct reference. Unless of course you're using interfaces, and we're gonna cover this in the future, where you can kind of get around this and have some different stuff. But yeah, that's generally it for events. Let's go a little bit over different uses. First things first is that you're gonna learn pretty fast that you don't want to use this event tick too much, just because triggering stuff every tick is usually not necessary. For stuff maybe like you want to update real time your UI or stuff like that, maybe you're gonna use event tick. But in general, you can do stuff, let's say every half second, every second. 1/10 of a second is pretty fast, where you can do some checks or updates every 10th second, and the player will basically not notice that, or every frame, which is maybe 60 times a second. One important thing for event ticks is that you can go to your class defaults, and then you can start or not start your actor with tick enabled. Usually I would advise, just when you create your actor, just disable tick in the beginning, and then if you really need it, you can enable it. If I understood correctly, they left this tick enabled just because people are getting confused. Where you create a new blueprint, you have this tick node. So if I create a new actor, we go to event graph, you just have this tick, and then you try to print or do something in it and it doesn't work, so people are getting confused. So I think that's why they left it by default, but you can disable it, just save a little bit of resources to not activate this. Other thing is that you can have intervals on your ticks. So if we go back to this guy and I set, let's say, 1 second interval here, and go to my test actor and disable unbind, we should get our print every second instead of every tick. So you can kind of customize it to optimize for performance. So that's also one thing to keep in mind. And you can use it similarly to timers, where I told you about how you can have timer that infinitely loops and then you clear it at the end. What you can do with ticks is, okay, let's do here delay. Let's do after 2 seconds, we want, or actually, yeah, we're gonna have to do this in event dispatch. So let's say after 2 seconds, set tick. So let's set tick enabled to false. And this way, basically after 2 seconds, we're gonna stop ticking. So let's try that. So we have 2 prints, and then that's about it. So you can kind of use similarly to timers, you can basically stop your tick at runtime, which is nice, but keep in mind if you have different stuff that needs to tick in different intervals, like you would have to have some branches in here, some tests, and it's gonna get messy, so you usually want to use timers, and for some really simple stuff you can also use ticks if you want. Also, when working with blueprints, try to take advantage of stuff that is already given to you by Unreal, which is stuff like endplay. So instead of managing when something is being deleted, you can use endplay, and then in here you can basically use conditions and see, okay, was it removed, was it destroyed, was there a transition in the level, so it wasn't like explicitly destroyed by the player, but we just changed levels. Maybe we want some special thing to trigger to maybe, let's say, save some info or something. So basically what is happening with this actor, you can use basically just event when it's specifically destroyed. You also have some stuff where the actor is taking damage, so there is whole damage system. If this actor took specifically point damage, you can get a bunch of information of what that means and how this actor maybe was damaged or how much health it was taken from him. Or you can do basically any damage, or you can have different stuff. And if we go to our test actor and let's say we pull from this event dispatch, we can type damage and you can basically apply damage. So you can apply just any damage, you can apply different damage types. So if I want apply point damage, so I can basically send this trigger that event, and then if we go back here, this event is going to get triggered, and then you can basically manage it here. So you kind of have already pre-made stuff that you don't have to create like a whole system from scratch. And you also have this icon, which basically means that this is going to be triggered on the server only. That's kind of just keeping it safe for you, because if you have multiplayer game, you don't want damage to be calculated on the client, because that just is a huge security concern where then clients can have control over their own health and can cheat easily and stuff like that. And if you're creating a single player game, the server is basically player's PC, so you don't really care if it's server or not. So that's just kind of their own solution. Yeah, so that's kind of about it for events. In the future, we might go in depth and actually start creating stuff with events, so you can kind of see good practices how you can use them.